To start any Node project, your first step is to create a package.json file to store general information about the project and track its dependencies. You can generate a package.json file with this npm init command and either keep the default answers or type new answers. We have a package.json file, which means we can start documenting and installing our dependencies. I'll install them one by one here so that we talk about them as they install.
I wrote an article on JS Complete about configuring a full-stack JavaScript environment for Node.js and React.js. I intend to regularly update this article and keep it recent and valid. The tools in the JavaScript ecosystem move fast and change their APIs and interfaces often. If you run into troubles while configuring your environment for this course, check out this article at jscomplete.com/reactful and see if you need to do something different.
We're going to have two types of packages. The main dependencies are the packages our code will use in production, and we'll have dev dependencies that are only used in a local development environment. Let's start with the main dependencies.
To create a Node web server, we're going to use Express.js. So that would be our first dependency here. npm install express. This command will install Express locally under the Node modules in this folder, and it will also write this dependency to the package.json file. Our database of choice for this course is MongoDB. To connect to Mongo from Node, we need a driver, and we will be using the official driver here, which we can install as npm install MongoDB. The I here is just a shortcut for install. Express and Mongo cover the main backend dependencies that we need. Our frontend is going to be purely React and nothing else. So let's bring in React here with npm install React and React DOM. We use the React library to describe our user interfaces and the React DOM library to render those interfaces on both the front end and the back end. We're going to introduce more dependencies later, but for now, this is a good start. Let's install our dev dependencies, the first of which would be Webpack. So npm install -D. This is to mark the dependency as a development dependency, and we need Webpack and Webpack-CLI. Since we're going to be writing modular code everywhere, we need a tool to translate modular code into something that browsers understand today. Webpack is the most popular tool for that job. This npm Webpack package here provides the library, and the Webpack CLI package provides the command for us to control the library. Now, Webpack itself is just the bundler. We still need to configure it with loaders to transform the JSX extension code into what React understands today. That loader is Babel. Babel will also transform a few of the modern JavaScript features that are not yet supported natively in all browsers. Here are the packages we need to make all that happen. npm install -D. We need Babel loader. That's the main loader that's going to invoke Babel. And we need a few other Babel libraries and presets to make the Babel configuration complete. We need @babel/CLI. The @syntax when it comes to npm packages is just a name scoping thing. So most of the Babel packages that we're going to use are scoped under the main @babel package. We also need @babel core and @babel/preset-inv, @babel/preset React, and @babel/plugin proposal class properties. I'll show you the configurations that we're going to need to use all these presets in just a little bit. Okay, we have the Babel packages. Now, when we make changes in a Node project, a restart is required for the changes to be reflected in any running process. But instead of manually restarting Node, let's bring in the nodemon package, npm install -D nodemon. This package can monitor our files and auto restart Node for us when we save changes to disk. One last development dependency. I am a big fan of ESLint, and I do not work in any project unless I have the eyes of ESLint to watch over my shoulders. I can't say enough about how important this is, but I hope you trust me on this one, and npm install ESLint, Babel ESLint to make ESLint work with Babel, and ESLint plugin React to work with the recommended settings for a React project. I will not go through configuring ESLint itself because it's beyond the scope of this course, but I'll add an ESLint configuration file that is ready to use for this project under the GitHub repo, and you can get it from there. One other production dependency I forgot, and we're going to use it in this course, is the prob types package. This is a React package. It used to be part of React, but now they made it its own package, and it will help us improve our React application. Okay, now in package.json, you can see the exact versions of all the packages I'm going to be using in this course. You'll probably see different versions when you install them yourself, but as long as you use a version that's on the same major version level here, which is the first number, you should be okay matching the experience I'll be going through here in this course. You can always install specific npm package versions using an @ after the name. For example, to install the same Express version I'm using, you can do npm install express @ 4.16.4, just like that. And also, you can just copy my package.json file as is and install the exact same versions I am using with the npm install command just like this without any arguments. I have actually forgot one Babel dependency looking at the dev dependencies list here. So it's a good opportunity for you to see how npm work with this package.json file. The @Babel CLI is only needed for deployment. We don't need it for development. What we need for development is @Babel/node. The version string here is automatically added by npm, but you can also manage it manually. For example, I can say, give me the latest @Babel/node, or maybe the latest on the 7 branch with this string. I'll keep this one 7.x. Now, when I npm install without any arguments, just like this, npm will refresh the node modules directory, making sure all dependencies are there. And because npm would not find the @Babel/node in there, it will download that and install it. I'm going to create an initial directory structure for this project now. First, let's have all of our JavaScript front-end modular code under a source directory. So I'll create a new directory here, src. It's a popular convention to name this directory source because it will be the source of our generated working files. Another popular convention is to have a public directory to host our static assets like HTML, JavaScript, and CSS files that will actually be loading on clients. We're going to have Express serve these public files directly with its static middleware. Finally, let's create a directory for our backend API server. I'm going to add empty files to all of these directories so that we can commit them to Git. So under public, we'll add an index.html, and under API, we'll add an index.js file. The index name here is usually used to reference the starting point in every directory. Let's now prepare our npm scripts. Now, we will not be doing any automated testing for this course, although that's probably a very bad decision, but I trust that you know the value of writing tests for your code. Testing is a big subject by itself, and I should probably create an online course just for that. The first script we need here is to run the Node server, which I'm going to put in a server.js file. So our start script here would be to node server.js. But since we want our code to work with Babel and nodemon, we need to add the nodemon execution wrapper. So the command here is nodemon instead of node. And we need to -- execute the Babel node command, not the default node command. This will make our server code understand JSX as well, which is something that we need for server-side rendering. We also need to ignore the public directory from the nodemon watch, as changes in the public directory are usually driven by changes in the source directory. Another script that we need here is a script to transform the source files into a bundle file for the browsers. Let me name the script dev, and the command that we need here is webpack with the -wd flags to also run in watch mode and in development mode as well. We'll need to configure Webpack now to work with our structure, which is a bit of a long story, but I'll copy some configuration here and we'll talk about them. Under the root of the project, we create a new file, webpack.config.js, and here's the configuration that we're going to go through. So in this configuration object, we tell Webpack to start from the index file under the source directory and bundle all the modules that we depend on inside the entry file into a bundle.js file under the public directory. Then, for every file that ends with a .js, we want to run the Babel loader on it. The Babel loader will take care of transforming the non-standard JavaScript that we'll be using. To configure Babel, we create another configuration file under the root of the project, this time babel.config.js. And here's the configuration file we're going to go through. This configuration instructs Babel to use the two presets that we're interested in, one to transform the JSX and the other for us to safely use modern JavaScript features and not worry about browsers that do not understand them. This plugin here is needed to enable the use of the new class fields syntax in classes, which is something we will be using in this course as well. To configure ESLint, we create a new file under the root of the project, and this time it is a .eslint.rc.js. And here is an example configuration object you can use, which you can find in the jscomplete.com/reactful article and the repo of this course as well.